Now let's see how can we compute 1 divided by x times ln x. Well, this is a very common question that comes with the substitutions for integration, because sometimes it will be a bit misleading. But as I explained you the elementary details in my first video of this playlist, if you see it correctly, you will eventually use the correct path, right? Now see, here we have 1 divided by x times ln x, right? Now if we have something like this, 1 over x or any power of x, right? We can of course use our standard rules to integrate this one. So the term that causes the problem is this guy, right? So let's substitute that one with a different variable, right? Now here don't substitute u for 1 over ln x, right? Because that's not the problem we have, okay? Because it's like simply if we have something in place of something small, or I mean less complicated in the denominator, we can use our standard techniques, right? So that's the key point that we have to target, right? Now when we have u equals ln x, then as we discussed before, we can follow the general procedure, differentiate this one and get the relationship. And see, now this is something else. Now if we use a different substitution other than ln x, those things will not work, okay? You can give it a try and see, things will get more complicated, okay? It's good if you give it a try, right? Now as we have this one as well as our substitution, we can replace the terms accordingly. It's like for this, you can, for ln x you can write u, and here in the relationship for du and dx you have something of this nature, right? So what I did is I rearrange the original problem in a way that it gives dx by x term. Reason is, when you have dx divided by x, you can directly replace that one with du, right? Otherwise you cannot just cancel dx and write du instead of that, okay? So we have this one. This is the same original problem, only difference is I have written x in here, right? Since this is a multiplication, you can write x times ln x as ln x times x, right? Now, so we have x in the denominator of dx, and that means we can replace it with du. So you have this one, and here don't forget to put the modulus signs, otherwise it is wrong, okay? Because you can get, if you write a negative term, ln x is not defined, right? And we have the arbitrary constant. Also don't forget to replace these new variables with the original terms, right? Okay, then let's move to the next question, which is the integral of x plus 2 times x squared plus 4x to the third power, right? See, all like at the very first sight, these might look a bit complicated, right? But it is not, okay? Now, so what we can do is we can just observe that the term that causes the problem is this one. So let's substitute that term with the general variable. Okay, and then if we follow the procedure, the derivatives will be of this nature, and the relationship, now once you differentiate you will get this one. Okay, and then you can see the original problem, we can interchange these two terms and write it like this. Okay, so what we have is this one, right? But if we just cross multiply the stuffs, it's not actually multiplication, but still that will make sense. If we write it like this, we might not have the exact terms in this problem, right? So we have to do the proper rearrangement in a way that we can replace these terms with du, but just at this first step these two are two different values. So what we can do is we can factor out 2 and we have du is equal to 2 times x plus 1, right? So where it is not x plus 1, it should be x plus 2, right? Then what we can do is, see here x plus 2 term is there in the original problem, but also we need to have 2, and hence we can write a 2 in front. But if we just leave it like that, we will be changing the original problem. So we have to divide it by 2 as well. Now altogether this will say that we have not done any changes to the original problem, because this 2 will cancel off with the 2 that we are multiplying these terms, right? So in a different way, this is the same as this one, right? Now we can replace this term with du, and here we have u cube, which is a very simplified term of integral, and we have the standard result for this one as u to the power 4 divided by u, and so we have the result. Don't forget to have the arbitrary constant.